So now we're going to do a system of linear inequalities. So the solution to a system of inequalities are where the two shadings of each inequality overlap. Okay, so on example 1, I'm going to graph this inequality and then this one as well. And when I see where their shadings overlap, that's where the solutions will be. Okay, lucky for us, y is by itself on both of those. Okay, so I know my y-intercept is a positive 5, so let's go ahead and put that. And I know the slope is a negative 2, so I know I'm going to go down 2 over 1. I can even change that to a fraction. So I know I'm going to go down 2 over 1, and I'm going to repeat that. So I put my y-intercept and I use my slope to move from point to point. Okay, so now I need to look at this symbol right here. This symbol right here will tell me whether I need a solid or a dotted line. There is no solid line underneath it, so I know I'm going to use a dotted line. This is also a greater than symbol, which tells me I need to shade above. So make a dotted line through these. That's not very good.
At this time, could you please complete your attendance for fifth period and release your 12th graders to the PAC Center? Thank you.
It's better. Okay, there's my dotted line, and I know I want to shade above. So you honestly probably want to use two different colors. So if you use pencil in this first one, you might want to pick a different color map color or a different color pen. So I use blue here, so I'm going to use blue for this shading. I'm going to shade lightly. Don't shade dark, please. Shade lightly, because I'm going to have to do another one on the same page. Okay, this one I'm going to use pink. I know my y-intercept is at negative 3, so I'm going to go down 3 and put my y-intercept. My slope is 1, which means I'm going to go up 1 over 1. So from my y-intercept, up 1 over 1. And keep doing that. Okay, to decide whether it's a solid or dotted, I look at my inequality. I see the solid line underneath, which means I want to use a solid line. I'll try making a straight edge this time, so my line's not so terrible. And it's solid. And then I see that this is a less than symbol, which tells me I need to shade below. Okay, I know my solutions will be anywhere where those overlapped. So where the blue and the pink overlap. So now I'm going to use a pencil and I'm going to make that area in darker. So this is the overlapping area here. Anywhere in the dark overlapping where the blue and the pink, that is where my solutions are. So all of these would be solutions. This would not be a solution because that's a solution only for the blue. I need it to work for both the blue and the pink, so it has to be where they overlap. So these are all solutions. Anywhere on this pink line, on this part of the triangle, these would work. If it lands on a dotted line, remember dotted lines do not work. So that might make you question this point right here, where the dotted and the solid intersect each other. It would work because it's on a solid line, but because it's also on the dotted line, this one does not count. Okay, so if it's ever on a dotted line at all, it does not count. So even though it's on a solid line, it's also on the dotted line, which means it does not work for both. So this point right here would not be a solution. Any of these would be okay. None of these would be okay. Everything on the inside, good to go. All right, lucky us, y is by itself. All right, so I'm going to start with my blue pen. My y-intercept is at -3, so I'm going to go down 3. My slope is a -2/3, which means I'm going to go down 2 to the right 3. I'm going to do as many as I can. Down 2, right 3. All right, and that's all of them that I can fit. Okay, so I see the solid line underneath, which tells me I need to use a solid line. So I'm going to line it up. I'll move it towards me a little bit. There's my solid line. And that is a less than symbol, which is going to tell me to shade below. So we're going to shade below lightly. Because I need to be able to see where they overlap. All right, so my next one, my y-intercept is 8, so go up 8, put a dot. My slope is 3, so I know 3 over 1. I'm going to go up 3 over 1. Okay, well, there's no room to do that, so I'm going to have to put it in reverse. So instead of going up 3 over 1, I'm going to go down 3, back 1. And keep doing that. There's a solid line underneath, which tells me I need to use a solid line. So let's go ahead and draw a solid line through those points. This is a greater than symbol, which tells me I'm going to have to shade above. So now I'm going to lightly shade above this pink line. So remember, the solutions are where they both overlap each other. So where the pink and the blue overlap each other, I'm going to use my pencil to shade in darker so I can know. Those are my solutions. So the pink by itself, nope, not going to work. The blue by itself won't work. It has to be where they both are. So where I shaded in that pencil dark. Okay, let's talk about here. What about along this line right here of the triangle? Because that's a solid line, that will work. Same for right here. That's a solid line, so any of these will work. At the intersection, it's a solid line on top of another solid line, so those are both good. This intersection would work as well. So all of this, and all of the shading. So remember, pause, rewind as many times as you need to. Okay, this next one, it's not as nice because y is not by itself, so we're going to have to put in some work. I'm going to go ahead and do this one at the top. So I have 5x minus 6y is greater than 42. Okay, so what I want to do is get y by itself, and I'm going to do that by taking away 5x's from both sides. That negative 6y falls down. So does the symbol, my inequality symbol. And 42 minus 5x is 42 minus 5x. Now I need to take both sides and divide by negative 6. The y falls down because my negative 6's cancel. Because we divided both sides by a negative, I know my sign has to flip. Okay, remember you have to take these one at a time. I know that 42 divided by a negative 6 is a negative 7. And I know a negative 5x divided by a negative 6 is going to be a positive 5 over 6x. So I know my y-intercept is negative 7, so go down 7. Put your dot. My slope is 5 over 6, which means I'm going to go up 5, right 6. That's all I'm going to be able to fit. So now I have to decide by looking at my symbol. There is no solid line underneath, so I know I have to use a dotted line. And let's go ahead and draw that dotted line. Line it up. That is a less than symbol, which means I need to shade below. And I'm going to shade lightly. All right, so that's that first one. I'm going to pick my next color. Since there's room underneath, I'm just going to work straight under it. I'm going to start by taking away 3 x's from both sides. 2y drops down, along with the inequality symbol. And that's going to be 14 minus 3x. Then I'm going to divide both sides by 2. So the y drops down. There's no need to flip your sign. First, I take 14. 14 divided by 2 is 7. Then I'm going to take negative 3x and divide by 2. That's going to give me a negative 3 halves x. So my y-intercept is 7. My slope is negative 3 over 2, so I'm going to go down 3, right 2. And keep doing that. Down 3, right 2. There is a solid line under my symbol, which tells me I need a solid line. So I'm going to go ahead and do that. Here's my solid line. That is a less than symbol, so I know I have to shade below. So I'm going to shade lightly below my pink line. Okay, so I know the solution is where the blue and the pink overlap, so I'm going to go ahead and take my pencil and darken it. Well, I know they overlap right here in this little triangle section. So that darkened section represents all of the solutions. So let's talk about the outer parts of the triangle. All of this, that would be on a solid line, so those would count. All of this on top of the dotted line, those broken lines, do not count. This intersection, yes, it is on a solid line, which is good, but it's also on a broken line. If it's ever on a broken line at all, it is not a solution. So this intersection right here would not be a solution. So all of this is okay, none of this, and all of this area. Okay, let's rework Let's get y by itself. 7x plus 3y is less than or equal to negative 24. I'm going to rewrite this. A little farther this way. First thing I want to do is I want to take away 7x's from both sides. That's going to leave me with 3y is less than or equal to negative 24 minus 7x. Divide both sides by 3. My y will drop down. There is no reason to flip my sign. I know a negative 24 divided by 3 is a negative 8. I know a negative 7x divided by 3 is a negative 7 over 3x. Okay, my y-intercept is negative 8, so I'm going to go down 8. My slope is negative 7 over 3, so I'm going to go down 7, right 3. I don't have room to do that, so I'm going to put everything in reverse. So instead of going down 7, I'm going to go up 7, back 3. Do it again. Up 7, back 3. That's all I'm going to fit. I know there's a solid line underneath, so I'm going to use a solid line. That is a less than symbol, which tells me I need to shade below, and I'm going to shade below lightly for now. Okay, for my second one, I'm going to change to pink. I'm just going to, I think I have room to work in under here. First step is take away an x from both sides. So I have 3y is less than or equal to negative 6 minus x. Then I need to divide both sides by 3. Y drops down. There's no reason to flip my sign. First, I take negative 6 divided by 3 is a negative 2. Okay, and lots of people mess up here. They want to tell me that this is going to be negative 3x, which is incorrect. This is a negative 1, right? So we have a negative 1 over 3. A negative 1 over 3 is a negative 1/3, and the x falls down. All right, so my y-intercept is negative 2, so I'm going to go down 2, put a dot. My slope is negative 1/3, so I'm going to go down 1, right 3, and keep doing that. Those are my points. It's a solid line underneath, so I know I need a solid line. And that is a less than symbol, which means I need to shade below. So I'm going to shade below my pink line lightly. Okay, so remember, it's not where the pink only is, it's not where the blue only is, it's where the pink and the blue overlap, which is this little triangle section here. So I'm going to go back and darken it in, so it's easier for me to tell. Okay, let's talk about the outer parts. So anywhere right here, this is a solid line, which means all of this is okay. Right here on this pink, this is also a solid line, which means it's okay. This little intersection right here, it's a solid line on top of another solid line, which means this intersection is good to go. So these are all solutions, these are all solutions, all of this is also solutions. Okay. So I'm going to rewrite this one out to the side. X minus y is greater than 3. Let's get y by itself by subtracting x from both sides. So my negative y falls down, my inequality symbol falls down, and I'm going to have 3 minus x. Okay, y is not quite by itself. I have to get rid of that negative, and I'm going to do that by multiply the entire thing by another negative. Remember, that's going to make everything opposite, which is going to give me a positive y. It's going to flip my sign, a negative 3 plus x. All right, so my y-intercept is negative 3. My slope is a positive 1, which means I'm going to go up 1 over 1. There is no solid line underneath, so I know I want to use a dotted line. And that's a less than symbol, which means I need a shade below. So we'll lightly shade below. Okay, I have x is greater than or equal to 6. I know I'm going to use Hoivux on this one. Since the inequality has x is greater than or equal to, I know I'm going to use Vux, which tells me it's going to be a vertical line. I know I see the solid line underneath, which tells me to use a solid line. And it is a greater than symbol, which tells me to shade above. Okay. All right, so I need a starting point still. So my starting point is going to be where x is 6. I'm going to go put a dot. And I'm going to draw a vertical solid line through that. And I wanted to shade above. Well, that's kind of weird to shade above a vertical line. So above greater than would be in front of it. So now I'm going to take my pencil, and where the pink and the blue overlap, I'm going to darken. So that darken area represents all of my solutions. Oops, sorry. So these are all solutions. Okay, let's talk about the outer areas right here along this pink line. Since it's a solid line, is good to go. Along this blue dotted lines, because it's dotted, those are not solutions. Let's talk about that intersection real quick. This intersection is on top of a solid line, but it is also on a dotted line, which tells you no, it's not okay, it's not a solution. So remember, never a dotted line. Never a solution on a dotted line. So no, 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 no. This little point right here, this is a no. All of these are yes. Everything in here is a yes. Okay, you can pause me real quick, or I'm going to do the work really quickly on this next one, and then I want you to try it on your own. So press pause, try it on your own, and then check yours with mine. You might want to check your equations before you go to do your shading. So let me go ahead and do mine real quick while you are working on yours. Try it on your own. Okay, if you need more time, make sure you press pause, or you're good to go. Check your work with mine. Okay, these are the equations you should have gotten. This is what your graph should look like. Let's talk about the outer areas. Along this side right here, this is a solid line, which means those do count as solutions. Along this outer area, that's a dotted line, which means none of those count as solutions. Everything in here is good to go. This little intersection right here, the point, because it's on top of a dotted line as well, this cannot count as a solution. So these are yes. Anywhere on the dotted line is a no. Everything in the shaded is good to go. So check yours, make sure it's right. Pause if you need to. Uh-oh. Hold up. Went through. All right. So keep working. I'm going to work fast. I want you to continue to work on your own. Check your work with mine. I know. Okay, so make sure you are checking yours with mine. Pause if you need more time. Let's talk about, no, check your equation, make sure it matches here and here. Make sure your graph matches. Let's talk about the outer edges. So like right here, this is all solid, so we know that this counts. Anywhere along this dotted line does not count. Even this little point right here where they intersect does not count because it's also on top of a dotted line. These are okay. Everything in here is okay. Anything touching that dotted line will not work. Okay, so part B is asking which of those are solutions. So it could be one, it could be all of them, it could be none of them. So let's check. The first point says, and you can see it on yours, A says 1, 3. So let's go check. So here is the origin. So I'm going to go forward 1, up 1, 2, 3. As you can see, this is in the dark shaded area where they both overlap. So yes, this is a solution. So I'm going to circle that. That was a solution. Okay, now let's try 3, -4, which means I'm going to go forward 3, down 4. This is in the pink only. That's not okay. The next one is at 0, -5. So 0, down 5. which is also in the pink only. That will not work. D says -2, 0, so I'm going to go back 2 and then stay put, 0. Okay, that one is in the dark overlapping area, so I know D is also a solution. All right.